Back in college algebra, you learned, or algebra 2, or whenever you did this, you learned how to solve an absolute value equation. And graphically, what we're trying to do is we're trying to figure out, if you get this, you can think of this like number 11 as two different equations. I want to know, when is that graph, or when is that function equal to 11? So I think, let me see if I can make a rough graph of this. And it won't be an exact, it'll just be a picture of this. This graph looks something like that, and we're looking for where does it cross that horizontal line, y equals 11. So we're going to get two answers, one of them on the negative side, one of them on the positive side. So we've got to take that into consideration when we solve absolute value equations. So one way I do it is I think about, okay, so whatever's in here, whatever's in that absolute value symbol, that's going to be equal to some number. Well, I know that the absolute value always makes it negative, so whatever's in there has to be equal to the negative number, because I'm just going to make the same number, only it's negative. And then I have another equation that I set up, and that whatever's inside there has to be equal to the positive of it. So then I have these two parallel equations I need to solve. They aren't systems equations, they're just two separate equations. Okay? So to solve 11, that's I'm going to use that idea. I'm going to say, okay, so I know that 5x minus 2 has to equal negative 11, because the absolute value of negative 11 is 11. And I know that 5x minus 2 has to also be equal to positive 11. So I'm going to solve this. I'm going to add 2 to both sides of this equation. So that gives me 5x equals negative 9. Then I'm going to divide by 5. So x equals 9/5. And if I look at this side, I'm going to add 2, so that's 5x equals 13, and x equals 13 over 5. So those are my two equations, and I should check. I'm not going to. You can. Okay. Let's try one like number 15 now. So the first thing we want to do is isolate the absolute value. So in something like 15, I'm going to solve it for the absolute value. I'm going to add 4. So 3 times the absolute value of x plus 1 equals 2. Then we're going to divide by 3. So if I divide both of these by 3, that tells me x plus 1, absolute value of x plus 1, has to be equal to 2/3. And now I can do that same trick. X plus 1 has to equal negative 2/3, and x plus 1 can equal positive 2/3. So that's going to subtract 1. What does that give me? Negative 5/3. And if I subtract 1, I get negative 1/3. Okay, so now we're going to put the same process into finding the horizontal asymptotes. So for one like number 17, we're looking for the horizontal asymptotes whenever you ask for. I'll show both of these in this video. But if we're looking for the horizontal intercepts, sorry, I've been saying asymptotes, whatever this graph looks like, I'm looking for where it crosses the x-axis. That's the horizontal asymptote. And any place along this x-axis has the coordinates x0, because y is always equal to 0, right? So that's all we're doing, is we're solving in this equation. So for number 17, I'm saying, hey, 0 equals 2 times the absolute value of x plus 1 minus 10. Now we're going to do that same trick we just did. I'm going to solve this to the absolute value, add 10, divide by 2. So that should be 5 equals the absolute value of x plus 1. And now we know whatever's inside there has to be equal to negative 5. And it also has to be equal to positive 5. So that's going to give me what? Negative 6 and positive 4. So those are the x's for those points. And we also know, my open math often looks for these as points. You got to kind of read it in context. So in this case, it would be negative 6, 0 and positive 4, 0. So you'll have to see how that's working. Okay, so hopefully that helps. I won't do another one of these. Now, an absolute value inequality, this is something that really comes in useful in calculus, okay? Being able to solve an inequality and figure out when it's either above or below some number. So graphically what's happening for number 21, I know I have an absolute value equation that's shifted left 5. Okay, and so then I'm going to draw a graph that's about 1 to 1. Let's see, I know it's going to cross here at 5, so we get a rough graph here. Alright, so here's this, and it goes like this, something like this. And we want to know, when is this equation less than 6? So here's the horizontal line, y equals 6. So I'm looking for, when is this graph below that line? What values of x make that y value be below 6? Okay, so what I'm doing is I'm looking for that x, whatever that is, and I'm looking for whatever x that is. Okay, and if this is a nice piece of graph paper, you could see that. How do we do this algebraically? Okay, so I don't know. Let's erase this. The best way to explain this to you is, I know that whatever's inside that absolute value sign is going to have a negative value and a positive value, and because it's less than, it's going to be in between. Let's see, let me get a red ink. It'll be in between those two x's. Okay, that's the solution set, where if I take any x value in that range and go up and hit the graph, it's going to be below the y equals 6 line. Whereas if I go outside that range and I'm off the screen, but I hope you can see that it's way up over that. It's up over that line, y equals 6. Because that's what we're trying to limit it at, right? So we're going to be in between these two numbers. And my best guess right now is I'm going to say 6. I know it has to be less than 6. So just like with an equation, remember how we made 1 be equal to the negative, 1 be equal to the positive? Well, what we can say here is we could write two inequalities, or I'm just going to write one because this is an in-between graph. I'm going to say negative 6 is less than x plus 5, which is less than positive 6. And then I can solve it, and I'm going to subtract 5 from all three parts. So negative 11 is less than x, which is less than positive 1. So that is the range where this function is below that line, y equals 6. And we could graph this. You go out and graph this in Desmo and see that and prove that. Okay? And I wrote this compound inequality because it's in between two values. When I'm going to show you how to do number 23, and that's an out. I had a teacher colleague that used to call this an innie, like an innie belly button, I guess, if that helps you. And this is an outie because it's greater than. Okay, so when it's an innie, we can write it as a compound inequality and solve it. When it's outie, we got to write 2. So now we're going to be solving a inequality where it's greater than. Okay, so what we're looking at is this graph. Let's see, it crosses, shifted right to. I'm doing number 23. Okay, so it looks something like that. And I want to know, when is that graph up above the line y equals 3, right? I'm looking for when is it above here and when it is above here. Well, I know that it has to be, x has to be less than, right? Less than whatever that x number is. And I also know that x has to be greater than whatever that x number is to come up and hit the graph. So that's what you do. It's going to be less than the negative and greater than the positive. So instead of, we're going to write two inequalities, and one is going to be x minus 2 has to be less than or equal to negative 3, and x minus 2 has to be greater than or equal to positive 3. This takes care of the greater than. This takes care of the less than. So I'm going to add 2 to both sides. And you got to remember all those rules about inequalities when you're solving them. And I'm going to add 2 to both sides. So that's solving that inequality. And that you can go check this on a graph if you want, a live graph, where this shows me that when x is less than, when that's negative 1, as long as I'm to the left of that, I'm hitting the graph. And as long as I'm to the right of positive 5, I'm going up to hit the graph. And that's how you solve absolute value inequalities.